Okay, this is going to be the third lesson in sequences and series. Okay, it says find the number of terms in the sequence. Once again, the first thing we have to figure out, is it arithmetic or is it geo? Okay, all right, we've been doing that a lot. Well, that's 9, that's more than that. So it's 12 divided by 3, second divided by first is 4. So times 4 times 4, so it's geometric. Then what I want to do is I want to create the explicit formula for it. Okay, we've been doing that a bunch. Okay, so if you look at the formula for geometric, it's an equals equals a1 times r to the n minus 1. Okay, now what I'm going to do is I'm going to put 3, all right, times 4 to the n minus 1. Now, here's the idea. Okay, I want to substitute numbers until I get 3072, okay? So what you want to do there is just play around with some of the math. All right, that's too big. All right, that's still too big. All right, there it is. Now how would I get 5? I would get 5 from 6 minus 1, all right? So if you wanted to actually check that, if you didn't believe that, you would do this. Obviously that's going to be 6. Okay, difference here is plus 12, difference here is plus 12, so this is an arithmetic one. Okay, so I got 3 plus, all right, n minus 1 times 12, okay? So you want to play games and substitute into there and see what you can get. So let's say I do 20. Okay, that's not enough. Let's go 25. I like to work in increments of 5 because then it's sort of like, well, all right, still not there. Let's go to 30. All right, now it's too many. Let's go to 27. Still too many. Let's go to 26. And that gets you 303. So that's the number of terms would be 26. Okay, this one, minus 31, minus 31. So this is an arithmetic one. I would set this up. Okay, same deal. Move this over here, see if it'll let me. Oh, well, good. Okay, so I got 89 plus, let's say 20 minus 1 times negative 31. Okay, it actually needs a little bit more. Let's go 25. Okay. A little bit too many, let's go 23. Okay, still too many, 22. Yep, there it hits negative 572, so that's 22 terms. Okay. This difference is 35. This is clearly not 85 divided by 50. Because a fraction is 17 over 10. If you multiplied 85 times 17 over 10, you get that. Okay, so I would want to use, this is a geo one, so I would want to use the geo formula. 17 over 10 to the n minus 1. All right, and I'm trying to figure out 477. Okay, so 50 times 17 over 10, let's say to the 12th. Okay, that's way too many. Okay, let's go like 8. Let's see if to the 8th power, how that is. Okay. All right, way too many. Let's go 7. Actually, I need to go bigger. What am I doing? I need to make that smaller by. No, I just got too many. Let's go 17 divided by 10 to the 6 power. All right. Now I went too small. Well, actually, and I multiplied by the wrong number. Sorry, my calculator's not great. Okay, still too many. Let's go 5. Still too many. I guess 4, huh? Yeah, it's 4. Okay, so how would I get 4? I would have 5 in there. Actually, didn't need that much more on there, so sorry about how long that took with the guessing, but you guys can go ahead and try those too. All right, given the sum and the type of series, okay, find the number of terms, okay? So what you have to do, very similar, is I have to use the sum, okay? All right, they're telling me it's arithmetic, so this is the arithmetic one. Okay, once again, all right, big thing I got to figure out is the difference here. Well, the difference here would be 6, right? Oops. Okay, so I got n over 2 times a1. A1 now is 17 plus, okay, n minus 1 times the difference, which is 6, okay? So it's the same kind of idea. I want to play around with that. Okay. All right. 1480. I need a lot more. Let's go 24. Okay, 2064, let's go up to 30, I guess. We'll go up to 40. Wish I could make that calculator a little bit longer. Okay, it's too many. Well, finally I got too many, so let's go 38. And this goes a lot faster, obviously, if you can hit keys on here a lot faster. All right, 38, getting closer. Let's go 36. Okay, let's go 37, I guess. Oh, whoops, I typed the wrong thing from before. This is frustrating. Oh wait, that's not the first term. That's why I'm not getting the answer. Typing the wrong first term in. Making calculator mistakes. There it is, 40. Sorry about that, I'm typing the wrong stuff in. Okay, geometric, okay. All right, that sum formula looks like this. Okay, so since it's geometric, I know this, the 6 divided by 3 would be 2. 1 minus 2, okay? All right, try to get 3,069. Same deal. 1 minus 2 to the 9th, let's say that that's that. Divided by 1 minus 2, a little easier, formula type. 1533, need a lot more than that. Let's go 15. That's way too many. Let's do 12. Still too many. Let's do 11. Still too many. Let's do 10. And there it is. So 10 would be the number of terms. So you're just guessing the number of terms. Okay. Am I doing 2 more of these? Okay, I guess I am. All right, arithmetic. So that means that difference would be 11. Okay, here's the sum. 2 times 5 plus n minus 1 times 11. Okay, I'm trying to get 3156. This one's a little bit more detailed. Try to get 317. All right, so that's that. Let's go 30. See if we can zero in on this just a little bit faster. Okay, too many. Let's go 25. Okay, still too many. So let's go 23. Or let's go 22. Just because it's even number. Not enough now. Let's go 24. There it is, 24. Okay, sum of a geometric series. Okay, so what I got is I got that first one being 20. All right, 80 divided by 20 would be 4. 1 minus 4 to the end, all over 1 minus 4. Okay, and I'm trying to get 436,900. Let's start with 10, why not? Okay, divided by, oops, that's not right. Sorry, it's not right. 1 minus 4 to the 10th, divided by 1 minus 4. That is too many. Let's go 8. That hits it right there. It's 8. Okay, so we're just making the explicit formula, making the formula for this, the sum and substituting. You guys can go ahead and do this. All right. So given the sum of the infinite series and the first term, find the rate. Now this one you can do a little bit, it's a little bit more simple to do this one algebraically. Because remember, this is the formula. All right, so what I can do is go 108 equals 36 over 1 minus r. Cross multiply that, which basically means 108 times 1 minus r equals 36. Distribute that, that's 108 minus 108r equals 36. Subtract 108, that's negative 108r, equals 36 minus 108 is negative 72. Then divide by negative 108, and you'll get yourself a fraction. Two-thirds. Okay? You could, in theory, guess, but the rate's a little tougher because it's likely to be a fraction. All right, so this one, (72), 54, 1 minus r, cross multiply. So that's 72 times 1 minus r equals 54. That's 72 minus 72r equals 54. Subtract 72. I would get negative 72r equals negative 18, and that would divide by negative 72. Negative 18 divided by negative 72 as a fraction is 1/4. And that would be considered the rate. Okay? All right, so those are pretty easy. You can go ahead and try those. Okay? All right, given the following sequence description, find the first term, the explicit formula, and the first term. Sort of already did this very similarly already. Okay? So this is an arithmetic sequence where the 50th term is this. Well, what we should do is figure out, all right, we sort of did a problem similar to this earlier in this unit. Okay, since it's arithmetic, this is what it would look like. I know this is the a to the 50th term. I don't know 50 minus 1, negative 6. Okay, so then I'm going to put the 50th term in here. All right, 50 minus, this would be 49 times negative 6. So 49 times negative 6 would be negative 294. I would add 294 over to the other side. That would give me a 1. So negative 276 plus 394 would give you 18 for the first term. Okay? Now, so what would that mean? Well, my first term is 18. The explicit formula now is easy to fill out because that's just going to be 18 plus n minus 1 times negative 6. The first 4 terms, that's sort of a recursive thing. So I can subtract 6. That would give me 12, then 6, then 0, then negative 6. Okay? And that's how you do that. All right? The geometric one, okay, very similarly, I got an equals a1 to the n minus 1. So I'm going to do a10 equals a1 to the 5 minus 1. Okay? All right? So what I would have here is a10 is this. Okay? Whoops, I need to put the 10 in there. So 10 minus 1 would be a1, 5 to the 9th. Okay? So then I do 2, 3, 4, 3, 7, 5, 0 divided by 5 to the 9th power. Okay, so as a rate, I got 3 over, or a1 is 3 over, was it 3 over 25? Oops, that's not right, hold on. The calculator's not great today. I swear I'm hitting numbers. I almost did it again. 3, 4, 3, 7, 5, 0 divided by 5 to the 9th. That's going to be 6/5. Okay, all right. So A1 is 6/5. Okay, so I got A1 is 6/5. The explicit formula would be this, 6/5 times 5 to the n minus 1. And then the next 3, I would take 6/5 and multiply by 6. 6/5, I'm sorry, multiplied by 5, obviously is 6. Multiplied by 5 would be 30. Multiplied by 5 would be 150. Multiplied by 5 would be 750. Okay, that's how you would do that one. Okay, you guys can go ahead and try those two. Okay, and that's the end of the sequences in series lesson. So for some of those first ones, what you want to do is get the formula as simple as you can. There is other algebraic ways to solve for those, Okay, if you want to actually physically do all the math, you could. You can also use the guess and check method as far as you get the formula and figure out what n needs to be in there for that to work.